welcome back. The title of this lesson is Motion in Cambridge's Best Papers. So I'm excited to teach this because we will reveal something we study in these two classes to the best papers, which is very important during our exams. Me and my team had collected some questions from paper 4 and paper 2 about this topic, motion. But we didn't find any questions for the last 10 years in paper 6 about this topic. So if you find, please leave that in the comments down or send us through the website. Let's get in. We will start with, so we could start with paper 2, which is a unit of acceleration. I'm gonna choose directly, it's supposed to be C because the unit of acceleration is meter per second square. An object is released from rest and fall to earth. During its fall, the object is affected by a resistance. Remember, in this word here, it has a meaning. Like if they said it's affected by air resistance, it means by passing the time, the speed will increase, but with a lower rate. I mean, the acceleration will decrease, or the body will, you cannot say decelerate, but the body, its velocity will increase with a lower rate comparing by before, as we mentioned in the previous two classes. The question is, the air resistance evidently reaches a constant value after some times. And remember, when we study forces, we're gonna mention that the air resistance will be equal to the weight of the body after some times. And this is what we called the terminal velocity in this case. Which description about the successive stages of motion of the object is correct? Constant acceleration, then constant deceleration. There is no deceleration at all. Constant acceleration, then zero acceleration. I agree with that initially. Decreasing acceleration, then constant deceleration. There is no deceleration here. Decreasing acceleration, I agree with that. Then zero acceleration, I agree with that also. But constant deceleration here, it's not that much right. So I'm gonna choose D. In question 3, which is the value of a vector quantity? For example, vector here, it means it has a direction. So I'm gonna write here C, 20 meters per second, and here is the direction. It means it has a direction, and also it means it is a vector quantity. In question 4, which distance time graph represent the motion of an object moving at a constant speed? Constant speed, it means the slope of the graph should be constant. This only available at D, because the slope here represents the speed or the velocity. So the speed of the body, it could be constant once when the distance time slope is constant. So I'm gonna write that here as a note, the slope equal to the speed, and the slope is straight line, it means it is constant. A car takes 15 minutes to travel a long road with 20 kilometers long. What is the average speed of a car? The speed usually equal total distance divided by total time. So the total distance here is 20 divided by the total time that we have here is 15 minutes, which is around 0.25 hour. Remember, the measuring unit here is hour for all. So I'm gonna write 20 divided by 0.25. It could equal 80 kilometers per hour. So I'm gonna choose directly C. In question 6, which distance time graph represent a body whose speed is decreasing? When the speed decreasing, it means the slope of the graph looks like decrease, because the slope is the velocity. And they said here, the speed decreasing, it means the slope should decrease. And I can infer that the slope decrease only in case of C. A, the slope is constant. B, even the slope is constant. Both, the speed is constant. For D, the slope is increasing if you compare it initially. If you have a tangent here and another tangent here, the slope becomes more steeper, or the graph becomes more steeper. So I cannot choose D. The right answer is C. In question 7, the graph shows how the speed of car changed with time, which calculation gives the distance traveled by the car in 24 seconds. That was easy. The distance is supposed to be the area under the graph, so I'm gonna just calculate this area. This looks like a triangle, and we know that the area of the triangle equal to the base, which is 24, times the height, which is 14, then divided by 2. So I'm gonna choose which one compatible with that. As you see, it's C again, 24 times 14 divided by 2, and the measuring unit could be in meter. Because this looks like speed times time, so the time in the measuring unit of speed will cancel the time for the x-axis, so we still have meter as a measuring unit. A car moves with a constant speed and then constant acceleration. Which graph is the speed time graph for the car? It moves with a constant speed and then constant acceleration. Constant speed, so I'm gonna choose this part. Then constant acceleration, as you see here, the speed is increasing with a constant rate because it's a straight line. So clearly I'm gonna choose C. And the next question, a car travels 100 kilometers. The journey takes 2 hours. The highest speed of the car is 80 kilometers per hour and the lowest speed is 20 kilometers per hour. What's the average speed of the journey? When I correct in this session, I observe many students, they just add 80 plus 40 divided by 2 and they choose C, and actually this is wrong. Because we didn't mention the time. Was the car moving with 80 kilometers per hour, and even we didn't mention the time for the car when it was moving with 40 kilometers per hour. So the best idea here is just take the simple law, which is the total distance divided by the total time. The total distance here is 100 kilometers and the total time is 2 hours. So I'm gonna choose that 100 divided by 2, it gives you 50 kilometers per hour. So I'm gonna choose B is the best option here. 10. What does the area under speed time graph represent? Clearly, the displacement or the distance traveled. The speed time graph shows the motion of a car. Which row describes the motion? I can describe it before you read the answer to avoid any confusion in this. So I could say in the first stage from P to Q, as I could see here in this part, the speed is increasing with a constant rate. So the car is accelerating uniformly, and then the speed becomes constant. I'm gonna choose something related to that. So which row describes the motion? So from P to Q, it's accelerating. Yes, I'm gonna choose accelerating. And between Q and R, the acceleration is 0, or you can say moving with a constant speed. So I could choose A. So the best option here is A. In the next choosing question, the graph shows how the distance traveled by a vehicle changed with time. Fine. Which row describes the speed of the vehicle in each section of the graph? Let's see. From B to Q, the speed is constant, so I'm gonna choose these two options, P to Q. From Q to R, the car at rest, so I'm gonna choose the speed is 0. 3 options we have. Then from R to S, the speed again is constant, but the car is moving in an opposite direction. So I'm gonna choose constant here. So the only option which is correct in the 3 choices is A, so I'm gonna choose A. In 23, the diagram shows the speed time graph for a train as it travels along a track. For which part of the graph is the train speed changing at the greatest rate? Greatest rate, it means the area in the graph which is the greatest steeper. So the acceleration or the deceleration is more in the area RS, so I'm gonna choose RS here, which is C. In the next question, a heavy object is released near the surface of Earth. and fall freely, air resistance can be ignored or negligible during the question. Which statement about the acceleration of the object due to gravity is correct? The gravity acceleration is constant, which is equal to 10 or 9.8 if they ask you to use this number. Let's read. The acceleration depends on the mass. No, the acceleration, it does not depend on the mass. It depends on the attraction force between the gravity and the object. The acceleration depends on the volume of the object, even though the acceleration is constant, yes, which is 10. The acceleration is initially 0 and increased as the object falls. No, actually the speed is initially 0, then increased as the object falls due to the acceleration. In the next question, an object moves at a constant speed for some time, then being to accelerate. Which distance time graph shows this motion? Constant speed, it means this area here. So I will not choose A, even I will not choose B. But this said in the second part of the sentence here, then being to accelerate. Accelerate, it means the slope of the graph becomes more. So I'm going to choose C. But when it comes to B here, the speed becomes 0, which is wrong. It's not compatible with the question. So I'm going to go to option C. In the next question, the speed time graph shown for a car moving in a straight line. Fine. What's the acceleration of the car when the time is 40 seconds? So when you go to 40 seconds here, some of the students did so. When I correct in this session, some of the students said, okay, in 40 and we need to find the acceleration. The acceleration means changes speed divided by time. So I'm gonna choose speed divided by time. The speed is 15 divided by 40. So the answer is C. And actually this is wrong. This is the wrong way. As we mentioned in the second class, we did in these questions, we need to draw the tangent. So if you draw the tangent clearly here, you will observe, the slope of this tangent is 0. So once when the slope is 0, it means the acceleration of the moving object is equal to the slope, so the acceleration is 0. So I'm going to go to option A. This is the correct one. In the next question, a stone falls freely from a top of cliff. Air resistance may be ignored. Which graph shows how the acceleration of the stone varies with time as it falls? The acceleration, it's not varies, the acceleration is constant. So I will go directly to option D because it shows that the acceleration is constant, which is equal to 10 meters per second square according to your syllabus. So please keep that in mind. If we ignore air resistance, it means the acceleration is still the same. If there is air resistance, so the acceleration will decrease, maximum decreasing to 0. It will never change into negative unless if there is any external force act on the body in an opposite direction of its motion. Keep that in mind. In the next question, they said the speed time graph for an object is shown. Below are 4 statements about the acceleration of an object. Which statement is correct? I could say that the body is accelerating initially, then the body stops accelerating with a constant speed, then the body decelerates from Y to Z. So we have 3 stages. Let's see. The acceleration in the first 5 seconds is given by area P. No. Area here is wrong. The acceleration increases between W and Z. Between W and Z, the acceleration is constant. Increases here is wrong. The acceleration is negative between Y and X. Between Y and X, the slope is negative, so the acceleration is negative, and the body is decelerating. So I'm going to go to that option. So I'm going to choose C. D, the acceleration between Y and Z is 20 divided by 25. Actually, we have no law for this. The deceleration between Y and Z, it couldn't be 20 divided by 25 because I know the speed, it's 20 divided by 25, 25 here, it's not the time, right? So this option is also wrong. The next question, a car travels along a horizontal road in a straight line. The driver passes the accelerator. A car travels along a horizontal road in a straight line. The driver presses the accelerator to increase the speed of the car. The speed time graph of the car is shown. What's the acceleration of the car? The acceleration is supposed to equal to the slope. So you can write that down. The acceleration equal to the slope. The slope here could be calculated by change in y divided by change in x. I could see change in y, it's that distance, which is almost 10, divided by change in x, it's 20, so it's 0.5. So I'm gonna go directly to 0.5 and choose it. So the right answer here is A. In the next question, the diagram shows the distance time graph for a car. At which labeled point is the car moving with constant speed? Remember, constant speed, it means constant slope when it comes to this graph. So I could see, here we have a constant speed, constant speed, and here we have a constant speed, and here also we have a constant speed. So depending on that, the right answer could be A. Dear students, that was fast. That was paper 2. Let's go directly to paper 4. In this class, I will take just one example about how the questions in past papers, and I chose this question. It was in 2013 May-June session, paper 3, variant 1. Remember, this is supposed to be variant 4 after 2015, it's V4. To just make sure that the question is extended, not core question. But anyway, this question, it was 13, which is, it was extended, not core. Underline the vector in the following list of quantities. Remember, vector, it's a quantity, has its own direction. So velocity, it has a direction. Force, has a direction. Density has no direction. Energy has no direction when it comes to Cambridge syllabus. Mass has no direction. Volume has no direction. So I'm gonna choose force and velocity only. Now let's get in motion question. A small metal ball is projected into the air with a velocity of 40 meters per second, vertically upwards. The graph in figure 2.1 shows how the velocity change with the time until the ball reaches its maximum height. Fine. So when we release the ball upward, when we throw it upward, the speed, when it was in our hands, it was 40. Then the speed decreased gradually in air until it reached, because of the gravity acceleration, it could be negative. So the ball, when it goes up, it could decelerate. So the speed decreased gradually until it reached to its maximum height. At the maximum height, the body should stop to get ready to go back. So when it's reached to the maximum height, and it happens after some times, this is what I can see from the graph. The time here is 4.1, as I could see. After 4.1 seconds, the body stopped at the maximum height, and the velocity, as you see here, is 0. Fine. Let's see the questions. Use the graph to find the time at which the ball reaches the maximum height. I can see that it's 4.1. Clearly, it's, 4.1. Even if you write it 4.05, but it's 4.1 because I have one decimal in the graph, so I'm gonna write here 4.1. So 4.1, do not mess the measuring unit, it's seconds and it's labeled over here. Anyway, the deceleration of the ball, the deceleration, it's supposed to be, so the deceleration here, it's equal to the slope of the graph, the slope equal to the deceleration. which change in y divided by change in x. Let's write that. Change in y, it's finally 0 minus the maximum y, here is 40, divided by the change in time, which is 4.1 minus 0. So it could be 40 divided by 4.1. Remember, this is negative because it's deceleration. So 40 divided by 4.1 is going to give you 9.9, or you can write approximately 10.0. So I could write here 10.0 meter per second square. Don't worry about the negative sign because it's written already, it's deceleration. So if you write it or not, it doesn't make a big difference because the deceleration is 10, or I could say the deceleration is negative 10. This negative means deceleration. So no doubt in this. It's 10 meter per second square when it comes to the deceleration of the ball. Triple I, the maximum height reached by the ball, it should be the area under the graph. So I'm going to say that the maximum height, or the height, is equal to the area under the graph. I got 1 mark out of 2 for this sentence, area under the graph. So I could find the area under the graph here. It looks like a triangle, and I know the area of the triangle equal to half times the base, which is 4.1, times the height, which is 40, right? So I'm going to say that it's half times 4.1, it gives you 2.05, times 40, approximately it could be 80. So I'm going to write here 80.0 meter. So I'm going to write 80.0 meter. This is the maximum height. Remember, you cannot find the maximum height depending on speed times time because we have no specific speed. Because I observe in this year some students, they did 40 times 4 and it gives you double of this height because actually the speed wasn't constant when the body fell down. So we have a range of speeds starting from 0 to 40. Thank you for watching. That was the end of the class. I hope you enjoy this. Please see these 2 classes to make sure that you understand the motion topic in a proper way. See you next class. Bye.